Right, previously we stopped at, I think we stopped at the decimal numbering system where I explained how you have to work out, the base 10 notations where you put it to the power of 0 and then you go to 3. So if you look at that, you look at the next slide, you understand what I meant by that. So if you look at the characteristics of a binary number system, we said that it uses two digits, 0 and 1. Your base numbering system, which is your your base 2 numbering system, and then obviously if you look at the example I showed you, is that each position of a binary number represents a 0 power of the base 2, example like that, right? And then the last position, right, the last position in a binary number represents a x powered to the base 2, for example x to the power base 2, as you see there, where the x represents the last position minus 1. That's why you always see it starts with 0 and then you go to its last position minus 1. What does that tell you? If you had to look at this here, last position minus 1, what does that tell you? It's 1, but minus 1 0. This is 2, but minus 1 is 1. 3 minus 1 is 2. 4 minus 1 is 3, and that's what it means by representing the last position minus 1. So let's just remember that, and that is what it means when you have to do your base numbering system. Right, moving on to show you an example. That's an example to show you really how you have to calculate decimal to binary. So if you look at this here, you have this binary number. Now this binary number is short. Remember, we used to show you the 8 bits. In this case here, we're dealing with 5 bits, right? So it's a 5-bit binary number, but that's not really what we need to look at. But this could be how a number you would get that you have to work out. And the way you have to work it out, so you have to follow these steps, as you can see here. So step 1 would be you have to write out the binary number, which obviously it's base 2, so that's why there's a 2 there at the bottom, right? And if you look at this here, this is kind of the calculation that you would use. So remember, this is just normal calculation, so this is without using the binary table. Remember the binary table, we had to work out the different classes and that. Now with the table in this case here, you're dealing only with 5, so you wouldn't have to write out the whole table. In this case here, you would have to use the amount of numbers that's there available. So in this case, we're going to 5, so you can do this because we're dealing with only 5. Whoops, that's bad. Fix that for you. Let's do that again. So let's do it that way. Hopefully that would keep the drawing straight, something like that. So we're dealing with 5, so that would be one block, another block, another block. Is that 5? No, that's 4, and another block. And then you take it through, and then you have that. So you're looking at 4. So let's say we have our binary, and our binary in this case would be, remember, it's 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, and 2 to the power of 4, right? That's what you have there. Now if you work out that, then you obviously get your numbers. So this is 1, that would be, what is that? 2, is that 2? Right, that would be what? So that's how you work it out, right? And then when you have your numbers worked out, you would then know what would be the equivalent value that's supposed to go in there. So as you can see here, we have 2 to the power of 4, and then you can see there it's 16. Why is it 16? It's 1 times 2 to the power of 4, which gives you 16. So obviously if you had to work this whole table out, you would know that yes, you would start at 128, you would start at 64, you would start at 32, and then you will get to 16, you'll get to 8, you'll get to 4, you'll get to 2, and you get to 1. But now we're not dealing with that extra numbers. You only have 5. Remember, it's a 5-bit number we have to work out. If you look at this here, right? So because we're dealing with a 5-bit, we don't look at these, and that's why I say you always work from your right hand side to your left. So you always start from that side, and then you can see here when you do the calculation here, you would see that you would start with your table. 2 to the power of 4 is going to be the the fifth digit in this sense, you know, so it's the fifth one, it's 50th, but you always have to write it -1 as the notation, right? So if you do the calculation here and you put this, like if you had to calculate this in which is a base 10, you would say 1 times 2 to the power 4, which is actually 1 times 16 is, you know, it's 16. Then 0 times 2 to the power of 3 is 0, right? Because it cancels out. 1 times 2 to the power of 2 is 4. 0 times, and now you really understand why I skipped the zeros when I did the long calculation in the first the first video we did live, where I said that it cancels out because you can't take the 0, but I had to do it in this calculation so that you can see really why I discarded the 0, because the 0 times that notation number cancels the number out, right? And you can see here everything that times 0 times 2 to the power of 1 is 0, right? You can see there. And then 1 times 2 to the power of 0, which obviously is 1, and then that will be 1, so it stays 1. So that is your answer, and then you add them all up. So in this case here, this person added all the zeros because it cancels it out, and then you have 21 as your decimal number with the 10 notation at the bottom. So that's just really how you have to write this out. So if in a not an exam or test, a class test would give you, and you have to work this out like this, then that's how you have to do the answer. You have to represent the base number that we know it's a decimal, that we know it's a binary. As you can see the number here, binary notation, and that helps you to really understand how the numbering system works. In normal terms you don't see this, but this is basically how the notations works, and the base or the radix. If you look at this here, it says 10101 base 2, which is binary. It's normally written as that. That's what I'm saying. You normally, in our case, if you have to do a calculation and this was kind of a question, then you have to put the base or the radix at the bottom. Alright? Hope you understand that. So that is just to explain to you really about the decimal to binary and to do it differently than what I've done it. And you know, maybe this would help you also understand really what's going on with the numbering system when converting from decimal to binary. The next video what I'll show you is the hexadecimal part. Thank you.